Okay. Uh, yeah, I hope my voice is clear for everyone. I can get started. Yeah, so agenda for today. Let me share the screen. Thanks for confirming. Just let me share the screen. A minute. Okay. Okay. So yeah, let's get started. We will basically discussing Azure today. Before we have a deep dive into Azure, let's try to understand few of the AWS concepts that I believe everyone is already aware, and this will help us to quickly revise few of the bits. Uh, like in AWS, there are multiple services that we know. One from networking, then other from storage, then you have compute as the categories, and then you have databases. In networking, there is VPC. Inside VPC, you have multiple subnets that can be created. Similar to storage, there is S3 as a service under which you you create buckets. Inside compute, there are multiple services, out of which EC2 is one of the service where you logically create instances. And in databases, you normally have RDS as a service. So two scenarios here. In case of Azure, we will first be discussing the fundamentals of what exactly Azure Cloud is and how is it same, how is it different from AWS. What are the key things that you need to know in case of uh, discussing the bits when we talk about Azure. So let's look at the services at a high level. What are those services? And we will talk about the basic services for now, discussing few bits here. So let's go back. Again, what is Azure Cloud here? Azure basically is uh, Microsoft as an organization which has their public cloud provider as Azure, just like you have AWS, which is Amazon's public cloud provider. The core fundamentals lies in the public cloud concepts. When we say public cloud concepts, we want to know everything from cloud computing, basically, then networking, uh, CIDRs, CIDR notations, and couple of storage services and virtualization. So all of this is very similar across all the three cloud providers. So when we talk about three cloud providers, we do have AWS, you have Azure, and you have GCP as a cloud market currently, where AWS has been there from almost, I believe, 2006 or 7, Azure slightly 2009 or 10, GCP on the same line. And whatever compute services that you normally have across each cloud provider, those will be available to you. Uh, again, name of the services would be different, but we will go through few of the comparisons as well for this one. So let's try to discuss a few of them. In case of AWS, uh, we know there is something called as regions, ideally. Just a second. So in case of AWS, we know there is region availability zones. The same region availability zone concept is also present in Azure, also present in GCP. So whatever we know from AWS, that AWS is spanning across multiple countries, across multiple regions. Same way, data centers are also available for Azure Cloud as well as for GCP Cloud. So going to those regions and availability zones, then at a high level, networking, there is few differences which we will discuss today. Then from compute side, one of the service that we will talk about, and from storage side, we will discuss one of the service. So at a high level, we will be focusing majorly on the fundamentals where, let's say if we discuss AWS, in networking, you have VPC, in compute, you have EC2, in storage, you have S3. Similar service in Azure cloud is called as VNet, which is called as Azure VNet. In EC2 as a compute service in AWS, the name of the service is called as virtual machine, which is VM basically. And for S3, when you create a S3 resource called as a bucket, in Azure, it is called as a storage account. So we will discuss the fundamentals to understand what are these concepts exactly. So we go back. Okay, then let's discuss this one. When we talk about Azure, Azure is again Microsoft product, and just like AWS, it has core sets of compute, storage, and database services. In many of the cases, the platforms have similar product and services. The way you have AWS, where you can launch Linux distributions, open source softwares, you can create multiple resources. Same way, you can also create resources in Azure Cloud as well. Both platforms are building highly available solutions as well as on Windows and Linux both. So you will see Windows servers, Windows Linux servers that can be launched across both the platforms. Let me see this one. Okay, it's fine. Then Azure is continuously expanding with the cloud services that will basically help you to get into multi-cloud environments. And yes, there are experimentations. If we talk about people using AWS for a specific use case, they are also trying and experimenting the same scenario on Azure and the same scenario in GCP. So there are few of the identical services are present in both cases. If we talk about the basics of both the clouds, for Azure, basically it provides you public cloud services geographically distributed across more than 60 regions, and you can access the services using internet or some private connections. It has a multi-tenant model where you can have multiple services running across your multiple subscriptions. We will talk about what is a subscription in Azure and what is an account. Again, consumption-based billing, which is normally the same thing on AWS and other clouds, pay as you go. You have your services that will be launched with a pay as you go model. Again, large number of service types that are ideally offered here. So if we try to look at the global infrastructure, this will take some time to load, but let's look at this one. Then the first thing is for you to be working on Azure Cloud, you will need a Microsoft account. So in this case, the link for the same is given. You guys can basically subscribe to the free tier account, and very similar to normally that we know in AWS, you get a free tier services, like you have AWS free tier for around 12 months, and there are specific services you get as a part of this free tier for this 12 months. In Azure, the free tier is slightly different. We will just talk about it in brief. You get around 14,000 as a kind of a credit in your account where you can launch any service in Azure for 1 month, and it also includes 12 months of few services which are free. So unlike AWS will give you some specific services throughout the 12 months as free. Let's say specific instance types in your cloud environment. For Azure, you will have the like some credited, some amount that would be credited to your Azure cloud account, and this will be available for you to use for 1 month. So you can ideally use any number of any service in your existing cloud environment in the Azure, and simply you can basically make things working. That's the small difference in the free tier eligibility for the Azure and AWS. And yeah, there are some steps given here. I think you should be able to follow this and get an account created. Now, what is Azure portal? So just like you have AWS console, which is going to provide you the UI capability to sign in. Just a second. Okay. I just okay. Am I already sharing the screen? Okay. For some reason, I got dropped off. I hope I'm audible now. Let me share the screen back again. Yes. Thanks for coming. So yeah, so we were talking about Azure portal. Basically, Azure portal is the UI using which you're going to look at for the services in your existing cloud account. So basically, this is how it is going to look like. Okay, and this is what you normally have for your let's say AWS console. So whatever AWS console you have, similar to that, you have a Azure portal. Again, you need to create an account in Azure, then you will get access to the Azure portal services. So let's try to see the differences again. If you look at here, it's basically a web-based tool that will provide you utilities to go through your Azure services. Azure portal is similar to AWS console. Along with Azure portal, uh, there is one service like we will discuss that Cloud Shell, recently been introduced by each of the cloud provider. It's present in AWS also, and it is also present in Azure. What is this Cloud Shell? In simple terms, uh, let's try to see the difference. Now, if you see this one, okay, this is one of the AWS account. If you just click on this icon here, this will open up a Cloud Shell, and this Cloud Shell is in AWS. You have a similar service in Azure. If you see this one, which is a Cloud Shell. So what is a Cloud Shell in the first place? What it does is, uh, previously when the service was not there, if you want to interact with your cloud environments, you would have to basically, uh, like you have an AWS account, and you can log in through AWS using your AWS console, basically. You can also interact with AWS using your CLI, which we know already. Uh, Basically, you can run AWS S3 LS commands, any number of commands that you have to talk to your AWS cloud. But to configure the CLI, Previously, when this services were like this Cloud Shell was not there, you had to download the AWS CLI package on your Linux machine, and then you had to set up authentication like AWS configure command. And this command, you had to enter the access ID and access key, which you normally create a secret key, basically, which you normally will create for an IAM user in your AWS account. So again, just to work with your CLI, you have to do a lot of mm, like too many configurations. You have to go with an IAM user and do these things. So AWS came up with Cloud Shell. Also Azure. We'll discuss AWS Cloud Shell. Simply what it does is in your Cloud Shell environment, you simply have this command line utility coming up. If this is already known for you guys, that's good. We'll just quickly see the difference here. You simply have this tool to talk to your cloud account, talk to your cloud environment. Basically, you can run AWS describe instances ---- region, and you can just list whatever region you want. This particular utility will have your credentials with whatever login user you have in your cloud account. If you have logged into the console with whichever IAM user, those permissions will already be available to you in this thing. You don't need to do anything here. The same concept goes for your Azure cloud also. This is Cloud Shell for Azure account. You click on this button here, it opens up a shell. Here you already have the AZ CLI that is already installed. So just like in your for your Azure account, you will be connecting with Azure using a portal like Azure portal, which is basically similar to this AWS console. You will be interacting with Azure using AZ CLI, which is a Azure CLI version. Same way you'll have AZ CLI, which is very similar to AWS CLI. And then the way you write commands, AWS S3LS, there will be commands which we will discuss, AZ compute, and then list instances, list VMs, similar to AWS. So interaction with the AWS cloud is first option, second option. There are again multiple ways to talk to AWS. You can also talk using programming SDKs or some infrastructure tool. You can talk to using AWS using IAC, which is basically Terraform. You can create resources. Same way for Azure, there are SDKs, programming SDKs, like let's say if you want to interact with Azure with Python or any other programming language, that is also possible. And also you can create resources on Azure using Terraform, which is kind of an IAC framework. So ideally, before again moving to these discussions, we will first look at some basic services. But interacting with the AWS and interacting with Azure is kind of very similar. Let's go back. Yeah. So we discussed the portal. This is how it looks like. And these are very high level services which are available. Again, this is all categorized into multiple categories, what we know here: security and management, application platform, data. Similar services, ideally you have categorized for AWS also. If you normally try to open your AWS account, you will see all of these categories here, and under each category there are services. Same way for Azure, there are categories defined in the Azure cloud on the left hand side, if you see this, and you have multiple services and multiple categories available. We will discuss just the brief of few of them right now, but there would be some comparisons that we can talk about it in detail. At a high level, these are the core things to focus more. Compute, storage, and networking. Compute is virtual machine, storage is blob, networking is VNet, and there are other services as well. Just like you have IAM services, you have your Active Directory service. In your Azure as well. And again, couple of services very similar to DevOps also. In cloud in Azure, there is Azure DevOps. In AWS, there is AWS CI/CD pipeline. So this is just a high-level services that Azure offers. Again, Azure Cloud is as it's as used as AWS itself. So it's not possible to discuss all the services in a day. You will take time, but it's always better to like compare the services over here. So if we talk about compute in the existing cloud environment, you have these details of let's say what are the different compute services available in your Azure. One of which we know, which is virtual machines, which is very similar to your EC2 service in AWS. It will help you to create, manage Linux VMs or Windows VMs in Azure. Virtual machine skill sets is very similar to scaling of instances in your AWS. Azure Container Instances is kind of a VM which will help you to launch containerized applications. It has Docker and container services. This all falls under compute. Okay, we will be primarily be looking here, but the services that are listed are for compute environment here. There is something called as Azure Functions. This Azure Functions is very similar to AWS Lambda, which basically helps you to have serverless computing. So basic difference between again, if we have to quickly understand serverless computing, what happens here is if you have to run a program, you need EC2 instances. You write a code, you write a shell script, and you make it run here. Or if you have to write a Python code. In serverless, in AWS, you have Lambda service, which basically you just write your code and simply let it run in the background. AWS will take care of the servers where the code will run. So similar way, you have in Azure, the service name is called as functions, Azure Functions. And again, this removes the need of executing code and you managing some servers. There are typical use cases. We cannot say at each level EC2 is going to be replaced by Lambda. There are some serverless web apps which can be developed, but at a high level, functions basically also falls under the compute category, where in Lambda function, you write a code and make it run. In Azure Functions, you just simply write a code and make it work. Basically, and this is used mostly for event-driven applications. So, like let's say if you have some event occurring in your any monitoring event or anything happening in your account, you can basically trigger a Lambda function or a Azure function to make things work. Go back. Then comes AKS, Azure Kubernetes Service. Again, this is like offering from Azure for compute category. Again, this is for similar to a tool in AWS called as EKS. So before you look into Kubernetes at a high level, Kubernetes will manage and orchestrate your containers basically. So it is used for container execution. For Kubernetes, AWS has a service, and the name of the service is EKS, basically Elastic Kubernetes Service. Simple architecture of Kubernetes, it follows a master node architecture and it follows a worker node architecture. Inside the worker nodes, your containers are running, and these containers are ideally running in terms of pods, basically. Okay. So if you have to set up a Kubernetes cluster manually, it is actually a tedious task. You have to launch servers and make things work. If you have to set it up on AWS, AWS has an offering called as Elastic Kubernetes Service. This EKS service will give you this managed node, the master node, not the managed node, as a And this is also called as a control plane in Kubernetes concepts. This is called as control plane, and this will be managed. This will be managed here. What do we mean by manage? AWS will take care of creating this host for you. In case of worker nodes, basically, these will be nothing but EC2 instances. This is EKS offering. Okay, you don't need to do anything. Simply tell EKS that okay, I want a 3-node cluster with Kubernetes version. These are the instance types, and you get an EKS cluster up and running hardly within, let's say, 20-30 minutes. A similar offering is also provided by AKS. Same way, you have a managed node where Azure will manage, you have a master node where Azure will manage the master node, and you have worker nodes, which are nothing but going to be VMs. So this will be VMs running, and Azure will take care of managing your master node in the Kubernetes cluster, and the virtual machine will be launched in your account, and you can launch your pods inside the virtual machine. So this is again AKS, which falls under your compute category. Okay, event driven. I think someone is mentioning step functions. Yes, there is a service in AWS called as step function workflow management. It is used for workflow orchestration. So you can have serverless services. Event driven can be serverless step functions running in your AWS environment to trigger your Lambda or any AWS services that you want. So yes, it can be used to kind of a workflow tool. It gets a UI and you can create your step functions. Okay, let's go back. So this is for compute. Now at a high level, this is what regions and availability zones that we were discussing. Azure has multiple regions again. I think I clicked on that link sometime back, the global infrastructure, and they kind of have a globe sitting down here where you can basically go through each details services that they are launching, across the which countries they are having all of this. You can basically go through those details in a map mode or whichever region, where in India, how many regions are there, in which countries, and what are the details about the infrastructure, like the data centers available here. So this is basically the global infrastructure. And yes, a region will be made up of more than one data centers, basically called as availability zones. Same way you have this concept in AWS as well. And yeah, there are some links given here which can be referred for more understanding. So yeah, you have availability zones under your specific regions. Now, one quick thing here. In AWS, you have accounts. So the architecture of AWS login, what you do, AWS calls it something called as accounts, basically. In Azure, you don't have an account concept. You have a subscription concept in Azure. That's the basic difference that we want to understand. In your AWS accounts, you log in, you create users, you normally authenticate to your AWS environment. In Azure, there's something called a subscription. Under a subscription, there is something called as a resource group. So what is a resource group? A resource group will be created for a specific region, and under this resource group, you will club all your resources. When we say resources, it may be a virtual machine, it may be a storage account, it will be your VNet or other bits. So all of these services that you're going to provision, those will be under a specific resource group, and a resource group is mapped to a region. So then we can say that if you have launched a VM in this resource group, this VM is ideally created in this region. I mean the data center of that specific region. Same goes for your virtual network and for your storage as well. So every resource in Azure will be created under a resource group. So we will see how to create a resource group and how you can launch basic scenarios here. So again, yes, this is what is one of the primary difference here. So yeah, there are some links again to go and launch your free tier account. Links are given here. What you can do here is just select this one, Azure Dev Essentials, from this particular thing, and just sign up with some basic details. Typically, the way you have kind of the way you create your AWS account, where it asks you for a specific uh, like some basic transaction to be done using some card to authorize the transaction, and they will revert that minimal amount back to your account. You will have a subscription created for yourself, and that subscription will be termed into the kind of a tiers basically, and you will be your free tier account will be activated basically for this one. So you go back here. Let's click here. So now this is how you create subscriptions here. So you will be signed up for a subscription for a particular type, kind of a free tier. And this is what I was mentioning previously. The benefit of Azure in free tier is it will give you a free account, which will have some 12 months services that are free, where very similar to AWS, the way you can launch, let's say T2.micro instance for 728 hours a month. In Azure also, you can do that. Specific VM types are available free. Apart from that, simply it gives you some $200 credit in your account, but this is again for 1 month. So you can use this to launch any paid service which does not come under free tier, and this amount will be kind of debited from this particular credit that you get here. Okay, so this is what you will get, and yes, this is the home page of your portal. Ideally, that will be used here. Now, in case of launching resources, when we say we want to launch some specific resources in your Azure account, there is something called as a Azure Resource Manager. So what does this Azure Resource Manager means? Going forward, we will be using Azure portal to spin up some resources. In the background, what it does is there's a API JSON, kind of a JSON string created, where it will submit basically a few requests to the Azure account in the background. And when you start provisioning some resources, the Azure Resource Manager will basically create a kind of a deployment for you where an infrastructure will be created. So that is what is going to be checked when you actually create a resource, any resource in your Azure account. Then resource group is what we talked about at a high level. Every Azure resource will be created under a resource group. So you will have a resource group created first. Inside this resource group, you will launch VMs, you will launch storage accounts, you will create VNets and any other services in Azure. So this is your high level architecture. Then resources groups are basically what you can have resources, one virtual machine talking to another virtual machine. All of that can be done, but the grouping happens on a resource group. And resource groups are created in a region that can contain resources, even from some outside region also. So you can have resources launched in a specific region, but yes, there can be some resources that can span across multiple resources across those RGs. So one resource group can have multiple resources created in that specific region as well. If we go back here now, again, I think we discussed the portal one. Okay. Now let's try to discuss few bits from the networking, like kind of the network model, basically that is followed in case of Azure. We'll try to compare how it is different or how it is same in case of your AWS environment. So in your existing networking concepts, we know what is basically CIDRs and all the networking topologies. CIDR notation for your IP addresses to be having an address space, let's say 8, and then this is broken down into subnets in AWS. And similarly, you cannot have subnets which will be overlapping the IP addresses. So that's what we know already in AWS concept. Similar concepts are applied in Azure also. So you will normally create a virtual network, which is called as a VNet. So going forward, VNet is as good as a VPC in Azure, in VPC in AWS, and virtual network has one or more IP ranges assigned to it. And virtual networks live within a subscription within a region. So in a specific region, you will have a VNet that can be created for a specific range. And this VNet going forward will be broken down into subnets. So typically what you do is you create a VPC or a VNet with, let's say, this range, and then you break it down with, let's say, this one with some 16 CID. And then this is one of the subnet, and then there is another subnet with the, let's say, 10.2.0.0/16. So this is how you typically make changes to your VNets, and you can create subnets. Then ideally, a specific virtual network that can be created. There are 65,000 like 536 private IP addresses that will be available depending on the specific range that you will select. Then again, in your VNet or in your VPC, if you want to compare few things here, just the way you have VPC and then you have subnets in AWS. In Azure, you have VNets and you have subnets. Then every VPC in AWS we know has a route table, a default route entry, a route table that is created. Same way in VNets, you also have a routing table that is available. In your, I mean, why do you even create VPCs in the first place and the subnets in AWS? For you to launch basically an EC2 instance. So when you launch an EC2 instance, this EC2 instance basically is going to be spinning across a subnet, where let's say this is your subnet, and this subnet is sitting inside a VPC. So this EC2 instance will have something called as a security group, and very similar, you call it as SGR. In Azure, you will launch a VM, which is nothing but going to be a virtual machine. This virtual machine will again sit inside a subnet, and this subnet will sit inside the address space of your VNet. Again, this one here, VNet, and you have a security group assigned to an EC2 instance, which controls your inbound rule. I mean, why do we use security group? You control it for inbound rule access and outbound rule. So very similar to security group, a virtual machine in Azure will have something called as NSG, network security group, and you will see something called as ingress rule, and egress rule. This is similar to ingress. Ingress means inbound, egress means outbound. So there would be an NSG. NSG means network security group attached to your VM, where you can control the IP addresses that will be launched. That can access your network. Then if we go back here, you have to basically have a VNet created, okay, in your account. In AWS, when you create an account, your AWS account, you get a dedicated VPC in each region. You might have seen that when you go to your AWS, when you go to any region, by default, AWS creates a kind of a VPC for you in each region without you even wanting to go and launch any resources in that region. But in Azure, it's slightly different. When you try launching a VM, you get an option to create a VNet. VNets are not created by default across regions in Azure, but you have to create it first, and then you can launch some resources in that specific. Then in case of virtual machines, in case of Azure, the virtual machines already have access to internet using something called as NAT concept, which is a network address translation. The public IPs inside that resource can be assigned to some virtual NICs or load balancers, basically kind of a endpoint that you can get here for your Azure VM. The virtual network and subnets have their own ACLs, basically enabling the subnet level delegation. So this ACLs is very similar to NACL concept in AWS, and subnet across availability zones. Whereas you can have in AWS, you have subnets spanning per availability zone. So in Azure, when you have a VNet in a region, your subnets can be sitting in any of the availability zone. So that is what is basically one of the basic difference here. So let's go back. Let me open one quick comparison here. So let's look at few of the resource that we can create here. So that will help us to understand few bits here. So we'll try to see, okay, let's say we'll see storage services first. So, okay, let me refresh this one. Okay. Now at a high level, we will discuss the storage creation, and then we will talk about, let's say, VNet and compute for now. So in Azure, there is something called as storage account. Let me open up another link here. Okay. So under the storage services, you have multiple types of storage services that are managed in Azure. Out of one is Azure blobs. Again, what is Azure blobs? Basically, for you to create a blob, you can refer this blob as kind of a object in S3. So normally what you do in AWS, you create an S3 bucket, and inside the S3 service, you create a bucket. Inside the bucket, you upload an object. So this is a high level hierarchy of what you store data in AWS. In Azure, what is going to happen now? We will look at Azure blob for now. You will have to create something called as a storage account. The storage account will help you to create something called as a blob container. And inside this blob container, you can create blobs. What is this blobs? This is nothing but objects, you can say. Objects, basically what you're going to store or what you're going to upload in your existing storage account service. So what is Azure blobs? You have a massively scalable object store for any text or any binary data. It also supports for any of the big data analytics like data lake storage for your Gen 2. So you can have this blob container mounted on any of your, let's say, any analytics environment, any big data environment that you want. And but you need to first create an account, storage account, not a account, storage account, SA. It's called as an SA. And then you can create a blob container and you can mount it to your infrastructure. Then there is something called as Azure Files, which is again a file share. Mostly use cases like some specific, like you have your file share can be used for some mounting of some NFS use cases in case of Azure. Queues are mostly messaging store for reliable. This is very similar to some queuing concept, like let's say files that you want to like data or objects you want to store as a part of queues. This disk is nothing but block level storage, which normally we know in AWS, which is EBS. So from your Azure storage account, basically, and from the blob, you have to first create a Azure storage account, and this Azure storage account will help you to create or upload data or download any data sorry. And then in the storage account, you can access the storage account via API, via CLI. Under the storage account, you will have objects, basically kind of a type of the storage account. The type of the account determines the storage services, where you have some specific type of storage accounts that can be created. These types of the storage accounts are nothing but you can create these storage accounts, let's say, to manage your existing infrastructure or your data, basically. And this particular objects that you will create will be a part of your specific type. And these are few of the types, basically list of redundancy objects. What this essentially means is in your storage, basically, there is something called as data storage redundancy. So when you store your data in a, let's say, locally redundant storage, what Azure does is in the background, it copies your data like in, let's say, in S3 concept. I mean, let's go back to S3 because we know S3 better. How does AWS, when we say AWS guarantees that, it will always give you your, it will always give you your data on S3. So it will guarantee that you will get a lot of data, durability of the data, and let's say your availability. So what AWS does in the background, S3 bucket is ideally in a region, which we know, and inside a region, you have multiple availability zones, AZ1, AZ2, AZ3. So when you actually upload an object on S3, in the background, you ideally don't know where is your object, okay, in the first place. We know it's in the region, but I mean, you don't know whether it is in which availability zone. So what AWS does is, AWS in the background will create copy of your objects, let's say in specific, or let's say it will replicate it by itself. And when you try to access the object, you may get the object from any of the availability zone. This is I would not say this is actually hidden. I mean, you don't come to know, okay, where is your object? But this is what AWS is doing it for you in the background to maintain that durability and availability concept of what they guarantee for their customers. You think that your object is copied once. Ideally, they will create some backups in the background for you. And in a failover of any of the availability zone, the data can still be accessible to you. So again, this is also in AWS concept, there is basically storage tiers option that are there ideally, which is, I think it is standard infrequent access, standard type. Then you have something called as standard, then there is infrequent access, and there are actually 2 to 3 more. So similarly in Azure, when you actually create a storage account, you have to select a specific type. Let's say when you say locally redundant storage, this is again a type where Azure guarantees, like kind of 11 nines of durability here as well in this particular fashion. In the background, it basically tries to make sure that your data is replicated across those three. It is replicated at least in the 3 physical locations. 3 physical locations in the sense, whichever region you will create a storage account, within that storage account region, you'll have availability zones, and those bits will be mentioned. So yeah, if I go back here, yes, this is Glacier, which we were discussing here. Then infrequent access, standard, and then you also have something called as one zone IA. Again, there are options where you can select these things. In Azure, basically it's called as a redundancy, data redundancy. So LRS is one. there's something called as geo redundant storage. What happens in this particular, I mean, the ideal way of storing data is kind of you want your data to be replicated across multiple geographical locations. So you can have your data replicated across multiple, and this will basically help you to make sure that your data is not only stored in one region, it will be stored in multiple regions. So let's say you have a kind of a primary region, and you have all your files are here, but there will be a secondary region uh, in Azure which will also keep a copy. So you will go with this option only when you are wanting to go with, let's say, cross-region replication across of your data, which is basically within this data center you will already have. So locally redundant storage means data is replicated within that same region in the physical locations. Geo redundant means data will be replicated across multiple locations. Then again, read access geo redundance means you have like a if you have to basically get the data only from the secondary region only for read purpose, you don't want to go and write it back, you will use this kind of tier. Zero redundant storage is as good as kind of the ZRS, which is the type. Again, here AWS, Azure, here it guarantees you 11 lines for one of this redundant storage that we're talking about. In sorry, it's zone redundant storage. It's not zero redundant storage. It guarantees you 12 lines. Like some extra layer of synchronous detail, synchronizing of the data that will happen in the background. So every copy of your object will be stored in all the three or almost all the availability zones available in that particular region. Then there is geo zone and read access geo zone. So difference between, again, you can select this in your existing while you create a storage account, we can select this. Again, there is some pricing available for this one. Normally, when you get started, you will always be using this one, which is basically the standard one. And what happens is in your geo zone redundant storage, your data will be synced across multiple availability zones, and it will also be synced across a different region continuously. And it is copied synchronously. So what do you mean by synchronous copy and asynchronous copy in very simple terms? Synchronous is real time and asynchronous is async, sync and async. Okay. In simple terms, if you have an object copied in, let's say, R1, which is region 1, you upload an object here. If it is a synchronous copy, this object is immediately backed up, or not backed up, replicated here. What do you mean by an asynchronous one? Object is copied here, but there's no guarantee that immediately it will be made available here. It will be made available here, maybe after some time, some few minutes, few seconds. So synchronous is real-time data replication across the regions, and asynchronous is basically kind of, it will take some time to make it work. Okay, so let's go back. Now, what is a blob storage? Is basically the object storage, which we know. Again, object storage in a sense similar to what you have your exact data or your S3 bucket. You upload some object. It can store massive amounts of data. Your Azure blob storage can store any unstructured, any type of data actually, and you can have thousands of simultaneous uploads, any data streaming or anything that you want to upload. There's no file type. You can just keep anything on your blob storage. And then one advantage of blob storage over the disk storage is you don't have to think about managing disk, because when you use the manage disk option, let's say for some servers, you do have to think about the elasticity of that volume to increase the size if you're going low on your storage. Data is uploaded as blobs, and Azure takes care of the physical storage needs. So that's how the service is doing the work. So now how do you create a storage account? Basically, in your existing Azure account, let's try to see this thing here. So you simply go to your existing let's say the portal, Azure portal. Okay, let me open this one. So you first need to create a storage account. So again, when you have a subscription available here, you will first need to create a resource group in the first place before even creating a storage account. Because what we said is every resource in Azure will be sitting inside a resource group. So before even you creating a storage account, you need to have a RG. RG can be named as a resource group. So we'll do one thing, we'll create a resource group first, and then we'll create a storage account. Again, if you go to your services, you will see this is resource group. You can even search any of the services here on the top. You can create a resource group. Let's say simply you mention the name of the resource group. Let's say easy fundamentals demo. We'll create a RG. Always it's better to uh, suffix every resource with the type so that whenever you look at all of your resources, it's easy to identify that, okay, if you suffix a particular resource with RG, it means it's a resource group. And again, the way you see here, these are all regions in your specific environment. And let's say we create East US for now, which is okay. You can assign some tags, which you can skip for now. Let's say create. So here, your resource group is created in a specific region, which is let's say East US. And under this resource group, you can create a storage account over here. So let's create a storage account. So you click on this resource group. Ideally, you can go to the storage account services here. Again, if you want to search any of the services, you can go via categorization, storage, and under storage, you'll see storage accounts. And under the storage account, you can say create again. And when you're saying create, you will get these resource group to be selected. So from the drop down, you select whichever resource group you want, inside which your storage account should be created, and some name. So the storage account name, again, needs to follow some basic like criteria, I would say, to get the storage account created. So let me just connect the where is the slide? Yeah, it's here. So if you want to create a storage account again, you can provide a name, but again, you will need a resource group first, so which we created already for now. And once you create a resource group, we just created a resource group, and then you go to storage account, and let's say you can create a storage account from that resource group. Then you click on the create option here, and you provide the details of your storage account. When you are on this page, you will have to provide the name for your storage account, something very similar to this one. And while you're providing the name, let me see, there was some format, like the storage account name should be unique. Let's go back here. Let's create some unique name. Easy fundamentals demo essay. Now again, it's always better to suffix your resources with essay. Essay means storage account. Then this will ideally be created in this East US region. And again, we'll keep it as standard. And this was the redundancy type that we were talking about previously. The LRS, GRS, and ZRS, this zone redundant, geo redundant storage. For now, we'll keep it as local. Then inside your storage account, you have, let's say, how can you access your storage account using some REST API? Do you want your containers? When you say containers, inside a storage account, there is going to be something called as blob container that we will be creating. So you have your RG here, Inside an RG, you have your storage account. Inside a storage account, you will create a blob container. And inside this blob container, you're going to upload your objects, which are ideally termed as your blobs. So this is the hierarchy: resource group, storage account, blob container, and whatever you upload inside this blob container are nothing but your files, basically, which you can create. Let's go back. Now, when you are actually trying to create a storage account, it is telling you, how do you want to access your storage account? From the security standpoint, there are multiple ways to access. One is your REST API, kind of a curl command, or you want to expose the endpoint. You will get an HTTPS URL, which can be used to upload or read some files. Enabling public access on internet on the containers, it means that ideally, if you have your container created, this container will have an endpoint URL, basically. So if you are on your local machine here, you want to upload some data inside the container, this can be exposed. Again, if you are outside your Azure network, you will need public access to the containers. If you're within the same resources, you can disable that option. Then let's go back. Enabling the storage account key access. There are multiple ways to access the blob container. We will discuss those when we actually try to look at some identity services. For now, we'll keep the default options in this case. Let's look at the steps here. Here you can configure some additional options where you can have the details selected, and let's go back here. Access tier is fine. Networking, you can enable the public access to your storage account. Again, this option enable public access from selected virtual networks and IP addresses. So if you have a restrictive environment, let's say, because again, this is very similar to, again, if we go back to AWS, so it's easy to compare. If you have an S3 bucket, if you remember, there was something called as VPC endpoint in S3 that you created. And if you launch an EC2 instance in your AWS, and this EC2 instance sits inside a VPC, okay? Ideally, we know EC2 is inside a subnet is inside the VPC, and every subnet also has a route table. So for you to access S3 service on AWS from a private, again, if you just go via IGW route, your access from EC2 to S3 will be an internet route in this case. And let's say you don't want the internet route. You want to go via private network. So what you do is you create a VPC endpoint, you add an entry of the VPC endpoint in your route table, and this entry that you add in your route table will help you to access your S3 on a private network, basically. So this particular steps can be used to access your network. In an ideal scenario, you can restrict your access to S3 in the VPC endpoint. There is a policy, basically, VPC endpoint policy, where you can source and whitelist that, okay, only request coming from VPC 1234 will get access to this bucket. So kind of, not allowing everyone to reach this bucket, but only allowing very specific IPs or networks or services to access the particular resource. So very similar things are also possible if you want to specify this, but for this one, you will need some virtual networks created already. But if you keep this now, again, you have to specify that in the storage account, basically, who can reach the storage account? Is it like all the resources? Anyone can reach the storage account? Or is it like from a specific VNet, any resource sitting in this VNet, they only can access storage account? So if you're trying to access the storage account from your local machine, it will not work if this is enabled. So this is kind of a segregation of security that can be placed. For now, we'll keep the default options for now. Then in case of, let's say, the data protection here, Let's look at the next tab. You can configure the options for data blob storage. You can also configure this post your storage account creation. Again, what this means is this is very similar to S3. There was something called as when you have some delete markers in S3. If you want to enable, let's say, uh, encryption, or if you want to enable kind of if you delete an object, you want to retain it back. So those delete markers are present. Or if you want a kind of a S3 life cycle policy that after 7 days, your changes will be done, and your modifications will be ideally done in case of objects will be deleted after specific intervals. That is also possible. So if we go back here, let's go to the basics. So we'll keep the basic options for now. Again, encryption is this is very similar to your encryption in S3. In S3, you have two types: SSE, server-side encryption, where keys are managed by AWS, and you have SSE with CMK. CMK means customer managed keys. So then you will have specific resources. Again, the data that will be uploaded on S3 buckets or the objects will be encrypted with the storage with encryption keys managed by AWS. Similar way, you have MMK. MMK means Microsoft managed keys. This will be your default option. Enable support for customers. So we don't want any support, but again, blobs and files, this is okay. Enable infrastructure encryption. This is one of the option where whatever resources are present on the storage account, Azure is going to guarantee one more layer of encryption. I think we can keep this blank for now. So you simply create a storage account, review all your details here, and say a final validation, and let's say create. So this will basically kind of, when you create these things using a portal, it will create a storage account. Now inside the storage account, basically this is kind of a deployment that runs in the background, where you said that okay, you want a particular storage account, and that storage account will be used to manage the details, basically in your existing environment. Okay, let's wait for this to get created. Okay. Okay, so now once your deployment is complete, you can go to the resource. So this is your storage account. Now inside this storage account, if you see the data storage options, a blob container, a file share, and a particular queues and tables which you normally create. And then these options are nothing but changes to your existing setup, where you actually want to, let's say, create a specific blob container. So you can go to the container here, and then inside, again, under a storage account, you first need to create a blob container over here. So let's say we create a blob container with easy fundamentals blob container, and this can be container private for now. So this particular resource, inside this resource, you will upload files. And again, you can upload files via manual. Just click on upload and paste the files here. Similar to S3 bucket, which you normally try to create. And then your files will be uploaded here. And again, these files will be available. So we'll see how to upload a file using CLI. That would be more easy. Let's go back. Okay, we discussed the encryption tab. We created the container. So yeah, we already created the container. Simply go to your container and click on the name, provide some name, set the public access for the container. The recommended approach is private. create the container for now. Once you create a container with a similar type, you can then even create a container from a CLI. Again, if we go back to the CLI, there are command line CLI queries that you can run, like commands basically that you can run. So let's try to, we can even try to create a container from the CLI. So what you can do is simply we'll go here. Let's try to put this option here. Now you can run this. The better option to run any CLI command is basically you go to this Cloud Shell. So here we go back here. Okay. Now this is where your AZ commands will run. If you want to list your containers, if you want to, again, we'll try to list the containers first. So it's easy to list them first, then we can create it. Okay, so you can say AZ storage. Okay, so AZ storage container list, and then your storage account name. In our case, the storage account name is this one. Let's go back here. Source groups. This one. Inside this resource group, you have a specific storage account here, and inside the storage account, this will be your name actually. So this is storage account name. Let's try to only run this one because we are already in Cloud Shell, so this should work. Okay, so you will need this AZ login command again before you try to access your existing services on your existing cloud account. You can basically say auth mode is login. What this essentially means is this particular services will be trying to create the kind of a login here. Okay, now what has happened is okay, let's try a simple thing here. What you do is you say AZ login in your shell. This will help. This will ask you to go to your browser. Okay, and let me copy this in the and then just simply paste this code here. And then once you authenticate to that login, those commands ideally should work. Let's go back. Continue. So it will ask you that, okay, were you trying to log in via CLI? And when you get this particular command, it means your credentials are embedded. Now you can say, okay, deleted, null. Okay, yeah. If you see, this is the container name. So AZ fundamentals blob container. This is the container that is already present in the storage account which you're trying to list here. This one. Let's go back. Close this tab for now. And if you want to create a container again, normally with this command, you can run this command, create a container. So let's try to run the same command with two options. One is create and the name of the container. And let's say we give the name as CLI for now. So AZ storage container create name, provide a name, AZ fundamentals blob CLI container. Account name will be the same, and this should be enough. Okay, so this is created is true. If you go back to the resource group. Under a resource group, you have storage account. Under the storage account, you have containers. So these are your blob containers. Inside these blob containers, you can ideally upload objects. So let's try to see it as well. So we saw create a container, list a container. You can actually delete a container using the similar delete command. And let's say if you want to upload some files, file upload is very common. That can be done using Azure portal also. Simply, if you try to go here, let's say this one, simply click on upload and you click your upload file here, any of the file that you want to upload, let's say. Okay, say upload. This file will be added in this particular container. Similar to S3 upload, which you normally do from your AWS console, you can upload files on your blob inside a blob container using the Azure portal. Or this is the file that is already uploaded here. You can also upload a file using your CLI, something called as this command. So you can say, let's say we create a simple text file locally on your Linux here. Okay, so you have this file here, test.txt. You want to upload it in your specific storage account, the container that we created now. So AZ storage blob upload. The account name means the storage account name, which is this storage account that we have here. And then container name, let's say this one. I want to upload the object here. And what object you want to upload, with what name you want to upload. And this should be enough. Okay. So this test.txt file is simply uploaded in the CLI container, blob container here, basically. Okay, go back here. This is your command here. Where is the, okay, this is your storage account. And this is your changes containers. And you have this CLI container where you have the files that you can upload. This one. So this test.txt was uploaded using CLI, simply just a upload command. There are again multiple commands that you can use. And normally, again, like you cannot remember all of these commands ideally. So better ways, the way you try to kind of navigate through the documentation for your S3 CLI. I mean, if you even try to, let's say we say EC2 CLI in AWS for one service, okay, you have so many commands, which is almost like 200 commands for one service. So you can never remember these commands. That's one thing, but you need to know how to use them. So for AWS, you need to know where you need to find these details. Same way, you can just search for easy CLI and you should get the command lines, the CLI commands for your storage services in Azure. Again, you need to follow the documentation for a couple of bits, but yeah, this is how you normally will interact with your Azure account. Let's go back. Okay. Again, the usage for blob storage would be serving images, documents, storing any audio, video files that you want to provision ideally. That's what is going to be the ideal usage for your Azure. For file share, you can create file shares. Basically, it is again a different type of like a storage service. Either one, basically, this is what is given here. Let's say if you want to create a file share here, again you go to the storage account, simply here. The second type of object is this one, and let's try to create it. Again, this will be having a specific type, and file shares would be mostly kind of acting as some NFS mounts to your some servers, either on-prem servers or any of those sites. So if you see file share, you just create a file share here. Let's say create, let's say uh, Azure fundamentals file share, and it will have some default tier type also. Okay, we didn't discuss the hot, cool, and this tier. There is very similar to warm objects and cold objects also in Azure, which can be used. So let's say we create this file share here, and you can normally create file share from the portal as well as from the CLI. And this file share can be uh, ideally mounted. There are few commands. I'll put down some links how you can mount it. But most of the scenarios when you're having some uh, kind of big data applications, or you want to retry data, you will be storing it in blob containers for object storage. File shares is more of a VM based kind of a NFS share in Linux that you can create and mount it. Let's go back. So you can create file shares, create a file share, select the file share, and just provide some file share capacity. By default, it should be 5 TB. Create file share using portal. I think we already did that. You provide a name, provide a tier, and create it here. Let's go back. You can also create a file share using command line. I think we can skip this command for now, but it should be a quick one. Creating file shares. So share rm command, then create. You need to provide the resource group, storage account name, what name you want, what's the quota size here, and output none is just one output way. So if you want to create this here, just let's say we'll do it quickly. Storage account, share name. Okay. So you will say, okay, the resource group you need to add it here in this command. So this is the resource group that we have. This one. Storage account is this one, which we added here. And then the file share name, whatever you want. Let's say you want this name. AC fundamentals file share. And then the access here, and you can put the portal. So this will help you to file share CLI. CLI file share. Run this command in your Cloud Shell, and you should be able to create a file share here. So this file share is created. This one, you go to your resource group, go to your storage account, go to the file share. Out of this, this one we created from the portal, and this one you created from the CLI. So by default, the quota in your CLI in your UI was 5 TB. Why this is 1 TB? This is because this is 1024 value. This kind of values that you provide here. Okay, let's go back. So this is how you typically create file shares, and some references are here. We'll now look at networking and let's say launching simple VM. We'll look at a compute first, and then we can look into the launching of virtual machine. Let's go back. So for compute category, we said that there is something called as virtual machine, and you can launch a virtual machine in your Azure. We'll try to see if we can launch it from portal. We'll connect using SSH, the same way you do a login for your EC2 instance. So again, what is Azure Compute? Under this service, you have multiple categories. We discussed this thing while we were talking about the differences. So that should be there. Then, okay, let me just quickly look at this one. So in your current compute environment, we have something called as virtual machine. Virtual machine is basically your Azure resource similar to your EC2 instance, ideally. So whatever you know in case of EC2 instance, you can create a VM using a in Azure as well. So just like EC2 instance. So VM is a service, and inside a VM you can have a server. So to create a VM using a portal, you again need to go to virtual machines as a service here. Go back virtual machines over here, and you can have, let's say, create here. When you say create Azure virtual machine from the drop down, and again you need to select which resource group you want your uh, uh, virtual machine to be created. Let's create it in the resource group that we provisioned it some time back, which is AZ Fundamentals Demo. Let's give a name. Let's say AZ Fundamentals VM. Specific region is selected because you have this resource group already there. Again, if you have a specific availability zone, or we can keep this option as default, should be fine. Security type, you can select the basic level of security in this image. Basically, this is very similar to AMIs, ideally, you have in your AWS, which is nothing but an AMI object. We'll select this Ubuntu 20.04 for now. Run with Azure Spot. Uh, this is very similar to AWS EC2 Spot. At a high level, what is the difference between on-demand and Spot instance? Just if you try to understand the concept. Let's take an example. You get a server for $1 per hour as an on-demand price. Spot instances, you may have to pay $0.3, but you have to bid for this price, and it will be on a size. Let's say if it is T2.micro, and your existing instance, I mean, ideally will not bid it for T2.micro. You may bid, let's say, bid it for M5.large. So AWS, in case of AWS, let's say the Spot scenario, AWS needs to have those servers sitting with them and no one using them. And if no one is using them and you give a bid for $0.3, you will get the instance. There are high chances of, I mean, you will get the server definitely, but this is Spot instances are not recommended for production environments. You have to go with on demand in your prod scenarios. Why they are not recommended? Simply because if you try to get a Spot instance, today you bid this amount, you get the instance. Someone else on the next day bids $0.6 for the same instance type. AWS or any cloud platform, whichever you're bidding this and you're getting a Spot requirement, they will terminate your instance just in no time, and they will kind of not. I mean, you'll not even get any notification. Some 2 to 3 minutes it will take for your instance to go down, and this instance will be assigned to someone else. So you may lose the instance. Okay, I'm not saying it will happen, but there's high chances that okay. So where in which scenarios do you prefer Spot? You will save a lot of cost in this one. Let's say development workloads, you are okay if your data or your machines are terminated, or any POC environment or POC setup here that you're doing. Always prefer Spot, but make sure do not go into production with Spot. And this is irrespective of whichever cloud you are ideally. Let's go back. So in your virtual machines, basically in Azure, uh, you have these particular virtual machine kind of types ideally. So let me just open those types here. The way you have types in your existing environment of your existing, let's say in EC2 instances, you have multiple types. Same way in Azure, you have types of instances. These instances ideally spin across these types. Let's open this thing here. Okay. So there are, let's say, general purpose, compute optimized, memory optimized, and Azure is having kind of a naming conventions it is having this DSv3, DSv3. There are again types here. We'll not get into the in detail understanding here. There are links given for each of them. But normally in AWS for compute optimize, you have instances like C5.large. For memory optimize, you have instances like M5.large. Yeah. For storage optimize, I think it is R5.large. So similar way, you have instances, instance types available in Azure Cloud as well. And the most general purpose type is this B size instances, okay, which ideally we can use here for now. So if you see the standard B1 is, which is basically one CPU and 1 GB memory. This is very similar to your T2.micro, which you normally launch in your AWS environment. Then the authentication type can be SSH key. Sorry. This authentication type is your SSH public key and the login user. Now, normally everyone knows when you basically try to log in your EC2 instance, you will normally put your details in your, if it's a, again, if we go back to the steps here, if it is a Ubuntu environment, you will log in with Ubuntu user. And if it is a Amazon Linux, you will log in with EC2 user. And what is the other type? Amazon Linux, Ubuntu. If it's a CentOS OS, you log in with CentOS machine. But in Azure, by default, if you don't have, if you don't provide anything, by default, your user login to your machine in Azure is Azure user. That's the name of the user that you should be using while you construct your SSH key. So simply you can say, I want to generate a new key pair and give me a new key with this name. Then again, selected ports, let's say SSH needs to be whitelisted. And this is what you can create. For the disks, by default, you have 30 GB. Same way in AWS, you had 8 GB as a root volume. Again, there are OS disk types, premium SSD, standard SSD. You can select standard SSD for now. There are again costing differences, very similar to EBS. IOPS, almost things are same, not much of the difference. Then if again this delete with VM is a flag, and this was also there in AWS, what it means is ideally when you look at these network entities in your cloud, an instance is a compute and your EBS is a different resource altogether. I mean, when you say you want a T2.micro instance, this is just compute. You have to have an EBS volume attached with it, ideally, which is basically 8 GB root volume, which you normally take. So these come together. I mean, you cannot have an instance without a volume, but there is a flag for this volume that's called as delete on termination. If your instance is deleted, volume also gets deleted. If you don't want this to happen, you can uncheck that flag. Now, next time, if you terminate your instance, your volume will still be sitting there in your account and it will be in an available state, basically, which you can again attach it to any other node. So this is that option. Data disk, yeah, this is if you want to add extra disk, you can select this one, but for now we'll keep it by default. Now, in the existing resource group, like we said right previously, Azure will not create VNets for you, okay, in the background. We are currently looking into this resource group and we don't have a VNet here, okay. But when you are launching a virtual machine, the ideal way of launching VMs or any EC2 instance, you cannot have an EC2 instance without a VPC. You need a VPC, you need a subnet, and then your EC2 instance sits inside a subnet. ideally. That network architecture is going to be same, irrespective of you're in AWS or you're in Azure. So you will need a VNet, you will need a subnet created, and inside this subnet, you will get your VM launched. So whatever you see here in your VM creation page, because in the existing resource group, which we saw, we don't have a VNet already. But on this page, it is going to create a VNet for you in the background. Where if you see in bracket, it is saying new. Again, if you had an existing VNet already, it would have popped up here in your resource group. So this VNet will be created here, and then you have a subnet that will be created here. Let's go back, and you may get a public IP, kind of a IP that will be assigned to your existing network. Allowed selected port, which is fine. SSH over here. This is what you should be clicking on. These are all going to be different resources. Okay, so when we will look at the Azure resource group, you will see that a different IP has been created here. Let's click on next. Go back to the steps here. Okay, yeah, this one we are doing it via console. Then okay, we selected the resource group. We selected the user. You put the user as Azure user for now, and you select the SSH port 22. For your VM storage, you select the disk. Azure will give you a specific disk that you can manage, and the default is 30 GB for now. So this is what you have. And then in your existing resource group, you can also, for networking also, we said that it will create a networking VNet in the background for you. And it will have some VNet specifications. We'll look at what are the basic specifications that are coming up. When you select the NIC here, there will be a security group that will be created in the background. So we will see these resources that will be created for you. Let's go back. So yeah, management, there are some basic checks that your subscription, there is something called as Microsoft Defender, which will try to scan your instance, the network that it will launch, and it will provide you some kind of advisory security management and threat protection on your instances. Okay, for now we can skip these basic options here. Monitoring, similar to CloudWatch, you can have basic monitorings enabled here, which we can just keep the default options for now. And custom data. Now, this custom data is very similar to your user data. Like normally in AWS, what you used to do during the EC2 launch, you wanted to install some packages, and you had to write some yum commands, and only during the launch. Okay, it can either be some commands or some script that you are storing on your location, which you want to run, kind of a init script during the launch. And again, user data only runs when the instance is launched. Okay, not when the instance is restarted. Okay, just you need to know this. Instance launch means first time when the instance is created, it will run. Don't expect your script to run every time you reboot your machine. Okay, it doesn't work that way. So similar way you can have the steps for your, I mean, you can enter the commands here, ideally. Host group, yeah, we can keep this details as default for now. Tags, you can add some tag. Let's say environment, and you're having this value step. Let's say you're creating it for dev environment. Go for review and create. This comes under free tier, so I don't think you should be price here. Let's say create. Okay. Now, just like AWS will give you a private key, okay, that you can download. Same way, Azure will also give you the private key, which you basically entered in the login. And then you simply create this virtual machine, and you basically go to the folder in which you have this particular key downloaded. In my case, I just have to make this key available here. You can go to your Git bash. I just have the key present here. Okay? Easy fundamentals. And then normally the normal SSH command that you use to log in. Okay, so this is deployment is in progress. And if you see this RJ VNet, okay, RG VNet basically, and the RG under this VNet there would be a subnet also created. Because you didn't have a VNet already present in your resource group, while creating of the virtual machine, your VNets will be created. And we also said that in AWS, your VPCs are created already in each region. So let's say if you are in US East 1, though you may not work on US East 1, you already have a default VPC available there. I mean, that gets created when you basically get a new AWS account in each region, and that is what it works. In Azure, it is not that way. In Azure, you just get a subscription, and inside the subscription, you create resource groups. Inside resource group, you have to create your own resources. And each time when you launch a VM, because you didn't have a VNet, it created a VNet, and your instance is now sitting in the VNet. So let's go back. Okay, so your deployment is complete. It means you have a server created here. Go to the resource, and simply this resource is having this top button. It means it is already running. It is started. The status is here is running, and this is the public IP of the host over here. So let's construct the SSH command. Simply SSH-i key.pem is your command. The login user in this case is going to be your Azure user, because you just launched this VM in Azure, and this would be the key name. So let us copy paste this here. So in this case, the key name will be replaced with this one. Okay. So we are inside the host, and this is an Ubuntu host 20.04, and you have this particular host created. And this is Azure user, very similar to AWS user, AWS EC2 user. And this particular user also has sudo permissions. So you say apt upgrade, let's say install, okay, yeah, this package, okay. Okay, it has sudo privileges. How you can verify that? You simply say sudo su, you will be switched to root. Yeah. So similar to your existing user, you have sudo privileges on this user. You can basically do whatever you want on this machine. Test user, any Linux command, and then just validate if that Linux commands are executed. And by default, these mount points that you have here, df-h, you will see this is your root volume /dev/root. Size is 29 GB, which is basically your in your when we launch the VM, the disk size we selected was 30 GB, which you have here, and you also get a temporary storage, if you see, of around 4 GB over here, which is basically kind of not as good as not an actual volume. You can call it as some ephemeral volume, like you keep the data, and if you delete the instance, the data is gone. So that kind of changes are there, and this will help you to basically launch your instance. And if we go back to your resource group, okay. So this is your resource group. Now, sometime back, we just had storage accounts. Okay, we just had this one. This one resource was there previously. So if you look at this, a key, an SSH key is also a resource. It is also present in your resource group. Then this is your disk. I think this is the 30 GB disk that we created. This disk is basically inside this resource group. If you see, disk state is attached What does that mean? This is attached to your VM basically here on this one, and the tags basically we had assign it to the VM, so those tags gets carry forwarded to all of your resources that were created, and that is this size is 30 GB. And if we go back here, if you see there's a VNet also created here, okay, virtual network, this one. So this is your VNet that got created on that page when we were launching the virtual machine. And this VNet again has this address space 10.3.0.0 and 16, this one. And inside this VNet, you can see this subnet here. This is a default subnet created here. And this particular subnet, which you have here, is having an address space. So it's very clear that if you go to the address space of your VNet, basically this one, this is VNet address space, and if you click on subnet, this is your subnet address space. So this is clear that this, this subnet CIDR lies within the range of your VNet CIDR, which is a cloud networking concept, which is also followed in AWS as well. So you will always have subnets sitting inside VNets. If you want to create more subnets, you can create it, but the address space for a subnet inside a VNet should be within the range of your existing this one. So here you created, this VNet got created by default when you actually launched the instance. You can ideally create your own VNet as well. We'll follow the steps here, and then we'll come back to the steps that we can create. You can create your own VNet with whatever like the range that you want. Let's say a customized range that you want, 10.0.0. Let's say 16. Okay, so it is possible. So if you go back here, and let's say again when you create a VNet, you'll have to give the resource group name, and in this case, let's say 10.0.0.0/16. Let's try to see if this can be done. Did we miss something? Oh, it's a name. Sorry. Is easy fundamentals VNet. Okay, and new VNet. Let's say. Let's try to see if we can give this range here. Okay, so these are the IP address that you can provide. I think we can provide it here itself. Okay, let's try to add here. Actually, in Azure, you can have multiple VNets, and those IP addresses for each of the VNets that we were discussing some time back will span across the start CIDR IP, and every VNet will have 65,000 IP addresses. So typically your address space for this one will be spanning across those specific VNet. And let's try to understand one thing which is a bit different in Azure in case of VNets. Okay, two things to note here. You're getting some errors here. This is something that we'll try to debug here. Okay, see what happens is in Azure, your VNets basically will have a specific IP addresses, and those IP addresses that you get in case of your existing environment, those will be spanning across a specific subscription. So ideally, if we try to look at these network entities, let's see if we have, okay, we were looking at what, delete this one. Okay, this was compute, right? Let me open the networking steps here. So we will just give me a moment. Open this document here. Yeah. So what happens is ideally, whenever you're going to create a virtual network, okay, you will have to provide a unique the IP address space. And what is going to happen? This is one of the example that we need to understand. When you create a virtual network, okay, you define your CADR block. Now this is important. This address space needs to be unique within your subscription and any other networks that you connect to. So for example, if you choose an IP address, let's say of this one, 10.0.0./24 as your first virtual network, okay? The addresses defined in this range would be this one. Let's write it down so it's easy to make sense out of it. And this is slightly difference in the way how virtual networks work, other than the bits, other things are same. Okay. So you have this range here, 10.0.0.4, and this will have the start IP as this one, and the end IP is this. So basically /24 is 255 IPs, and it will start from one, end it till here. And then if you now try to create a virtual network and choose an address space of this one, okay, you have your VNet 1 already created here, and you have your VNet 2 that you're trying to create here. For this one, your IP addresses, okay, are spanning here. So this, okay, first of all, we know that this is a larger CIDR range. So the number of IP addresses is less. So I mean, again, larger the CIDR subnet mask, lower the number of IP addresses. Lower the number of subnet mask, larger the number of range. I mean, the range is higher basically. So you have 10.0.0.1 to this one. Now you will see that this space 10.0.1 till here, this VNet which you're trying to create, this range is already occupied by this VNet. So in this case, some of these IP addresses are overlapped and it cannot be used in two networks, but you can use this one. So what you need to be, what you should be doing is, you should be creating VNets with smaller chunks and making sure that the CIDR notation of your VNets doesn't overlap with the VNets that you have in your existing account. Okay, so you then create a second. So this will not be allowed. That's what we're trying to say. If you have a range already created here and you try to create this range, because in this range this is overlapping. And why are we saying this? Because again, within a subscription, your VNet address space should be kind of unique, is what is the fundamental networking address space network CIDR logic that you have to look at. So in simple terms, this will work, okay? But this, because this address is already overlapped here, you may not be able to create a VNet 2. But if you create this virtual network here, the address space for this one, let's see, let's go back here, that you can use this one, which is here. And this particular VNet with the address space from this and put this one, okay, 10.1.0.0 will work, because this is spanning from 0.0.1 and this is ending at 0.0.254. So you can use any other ranges, 1.0, 2.0, 3.0. So this way you have to segregate your virtual networks across your cloud environment in your Azure, just to make sure that your VNets doesn't overlap. Now, what is happening in this case here, what you see here, I already have few of the VNets sitting here. Okay, if I go to virtual networks, if you see, I already have, let's say, this VNet created here. This is what we created some time back. We can create another VNet, which is not, let's say, not in this specific range. So let's try to do that. What are the existing VNets that we have? Let's go back here. This is 1, this is 2, this is 3. And let's say we select the resource group as this one. You can have a VNet, let's say 10.2.0.0. So that's the name. So dev check VNet. Let's try to see the address space. It is actually giving you 10.4.0.016. So this will span across your existing one. So this is what you can use. Let's try to create a subnet. And if you see 10.4.0.016 is here, and default subnet is here. You can add one more subnet if you want. Let's say test subnet and give a range. So this range should be within this range. So let's say, okay, we can give 10.4.0.024 is already occupied. Overlaps with this one. So let's say we say 1.0. Okay, so this should be fine. So this can be 0.0, which will span across 0.1 to 0.255. And then you can start with 1.0, and then this will span across 1.0 to 1.255. So this way you put the chunks of those subnets. You can add it here. And then once you create a VNet, along with the VNet creation, these two subnets will also be created. Again, during the creation of a VNet, there are specific rules. Rules in the sense, when you will create a subnet, you will have specific kind of a this type here. Okay, in the security, this bastion host, basically what it means is this will help you to provision your like a virtual network. It provides some secure and seamless SSH connectivity to your machines. Normally, when you try to like basically this shell what I have opened here is from the client or let's say a local desktop machine. When you're trying to connect it from this machine to your VNets, internally Azure manages some SSL like a transport layer security rules, which will help you to kind of make sure that your connection is more secure in SSH. The login basically to your host. So you can basically provide some ranges here. For now, we'll keep it as default. DDoS protection standard. Again, it's a paid service. This will be monitoring your networks or your instances sitting inside your VNets. And firewall, basically cloud-based service, which will make sure that it. So this is very similar to firewall or WAF WAF in your existing setup. So for now, we'll keep it as default. Create. Okay, so this is your VNet, and inside your VNet, your subnets will be created here. Let's say create, and let's go back. Let's put this changes here. So this VNet will be provisioned in this particular host. And same way, the way we launched a virtual machine in the previous step, you can launch another host, let's say. And this time you can select the VNet that you created from the dropdown. Okay, let that VM get created. We'll just see the steps. We'll not actually create it. You guys can do that. Here from the drop down, give some name. Test VM name, and the resource group can be existing one. In your networking tab, this is the one that you can select. This is the VNet that you created in the previous step, and you launch your VM. In your existing VNets here, and inside this VNet you have subnets created here, and you can launch your VM in any of the subnets here. So this is kind of the overall basic fundamentals is what we can say for now. Yeah, I think we mostly covered these services at a high level summary. We talked about Azure, we talked about Portal, and we also talked about CLI, command line interface with Azure, and the core basic services in networking. You have VNets. Inside VNets, you can create subnets. Then you have storage account. Inside storage account, you can create blob containers. You can create file shares. And inside your VM as a service, you can launch a virtual machine. So virtual machine itself is a service name, and the resource that you launch in the service is also called as virtual machine. So this is how instances can be launched. Again, you can do SSH pretty much the same way you do SSH in your host with the key pair. Okay, I think it should be good for now. Any quick queries that we can talk? I will share the slides with everyone, and yes, you can basically go through this so that it's easy, and always look upon for all of the services from a comparison standpoint. Few naming conventions will be same, but there would be some deviation in the way they work. But yeah, this is how it can be done. Okay, how many services? Okay, see, at a high level, you should be focusing on, let's say, Azure, the core services, the database, the networking service, then compute and storage account, at least for now. Again, if you have to specify what you have created, it could be a POC setup that you are actually working in case of your existing environment. Again, these services that you have here, okay, we'll try to see, again, we saw these services can be created using your Azure portal, also using CLI. We'll try to map some more concepts from the services, and also these services can also be created using Terraform. Okay, so similarly, you will have those resource creation can be done using Terraform, because typically Terraform will help you to like create instances or create resources in AWS as well as in Azure Cloud. But always remember, Terraform or any other infrastructure automation tool, if you don't know how this resource in Azure is created manually, it would be difficult to understand how it is being done using Terraform. Because in simple terms, when you actually talk about any automation service, what is automation? It is some steps that you know how to do manually, and there is some service that you introduce to make it work automatically. Now you tell this service what to do. This service will do what you have instructed that tool to do. So yeah, always if you are again looking for Azure infra creation using any tool, first it's better to understand the service using portal. Try look at the navigations. There are too many concepts around each of the option that you will select, and for that each of the option in your Azure portal, you have a kind of a parameter or a configuration that can be used here. So that is how your changes are available here. Okay. Okay, I think we should be good for now.